Hello, chemistry fans, and welcome your faces back to Learn More Time, Chapter 7, Problem 1. Hello, chemistry fans, and welcome your faces back to Chemistry 1032 Problem Solving Session. My name is Dr. Russell Betts, and I'll be your host and guide through these problems. So let's jump right in. Chapter 7, Problem 1. If you have 0.25 moles of aluminum, how many atoms of aluminum do you have? Ladies and gentlemen, this is a simple conversion question. Students often have problems with it for some reason or another. It's simply a conversion factor. You just have to know what conversion factor to use. We know there's this number called Avogadro's number. We know that it is 1 mole of anything equals 6.02 times 10 to the 23. Anything. So 1 mole of anything is 6.02 times 10 to the 23 of anything. So let's be more specific. If I said the word a dozen, you would know that the word dozen means 12. So if I have a dozen donuts, I have 12 donuts. If there's a dozen people in the room, there are 12 people in the room. It's simply a word that means a number. The mole is the same thing. The mole is a word that means a number. It means 6.02 times 10 to the 23. And that's it. That's about as complicated as it gets. So now, in chemistry, we tend to say if I have 1 mole of an atom or of an element, I have 6.02 times 10 to the 23 atoms or molecules or ions. Okay, so that's what we generally use it for in chemistry. So let's set up this conversion factor. I'll show you how. It's very simple. So we're in moles. So I have moles multiplied by something to give me, what do I want? I want atoms. All right. Same as every other conversion factor problem we've done, I will put moles on the bottom. And I will put atoms on the top. By doing that, through the wonderful magicness of mathematics, the moles will cancel, leaving us with the unit atoms. So let's type in some numbers. I have 0.25 moles of aluminum. So I put moles of aluminum on the bottom, atoms of aluminum on top. So the number 1 goes here, comes from here to here. 6.02 times 10 to the 23 goes there. So that's how you set that up. Very simple. Units cancel, leaving me what I want, atoms of aluminum. Grab your handy dandy calculator. Type in 0.25 multiplied by 6.02. Now on this calculator, here's how we set up the exponents. 23. Your calculator is probably going to be different. I don't have the time right now in this video to show you how to use every calculator that I've ever seen before, but I'm sure it's pretty self-explanatory on your scientific calculator. If not, ask one of the tutors here at the Academic Success Center how to set up exponents on your particular calculator, or come and see your professor. Most of us have seen pretty much every kind of calculator there is out there. And then once you set in your calculator, hit equals, and there is my answer. But don't forget significant figures. We're multiplying. So here are 2 significant figures. Here are 3 significant figures. My answer can only be in 2. So the answer will be 1.5 times 10 to the 23. And let's put a box around it. Wrote on the table, don't tell anyone. Shh. All right, so that's how you do part 1 of this problem. Now, let's look at part 2. If you have 3.45 times 10 to the 34 atoms of gold, how many moles of gold do you have? So again, it's a simple conversion factor. We know Avogadro's number. By the way, if you're in my class, Avogadro's number will be written on the formula sheet. You do not have to memorize it, although I'm sure by simple repetition you will remember it. So there's our equality, which is going to become our conversion factor. Remember, it can be moles of anything, and this unit over here can be anything you want it to be. Generally in chemistry, it's atoms, which is what we're going to use today, molecules, or ions. All right, so we have atoms of gold. So let's put atoms of Au right here, multiplied by something that's going to give us moles of Au. All right. We know, because we've done it 1,000 times, atoms go on the bottom. And moles go on top. How do I know that? Because I want the atoms to cancel. That's how I knew to do it that way. Let's put in some numbers. We have 3.45 times 10 to the 34 multiplied now. Be careful here. We want the moles of Au on top. So mole number 1 goes on top. 6.02 times 10 to the 23 goes on the bottom. How do I know? Because the one went with the mole, this goes with whatever other unit I have. So this could have been atoms. For example, this goes on the bottom. Okay? All right. Bust out your handy dandy calculator again. 3.45 exponent 34 divided by 6.02 exponent 23 equals. And let me see here. One more time. I think I might have typed something in the calculator incorrectly. Let me just make sure. Oops, that's probably why. All right, guys, cut the camera here. I want to just double check that answer. I'm not sure I'm getting the right answer with this. So cut, and we'll have to splice together here, unfortunately. I think I'm typing it in the calculator wrong. This could be right. It just seems really high. All right. Makes sense, I guess. All right, let's pick it up again. How about we start? How about we go back to where I brought the calculator in the first time? So let's go back to where we brought the calculator in the first time, and we'll do it from there. So cut right before I bring the calculator in, and then start right here where I'm bringing the calculator back in. All right, so let's calculate how many moles we have. Plug in some numbers. 3.45 exponent 34 divided by 6.02 exponent 23 equals 5.73 times 10 to the 10 moles of aluminum. So we have quite a bit of aluminum present there, which is a good thing. Not aluminum, gold, which is a good thing because gold is worth a lot of money. Now, with that, I hope that you're able to solve these problems. If not, raise your hand, go find a tutor, go find your professor, do something, get this straightened out, get it straight, get it right. You can do it. All right? With that, I'd like to say good luck and good chemistry.